Hi, welcome back. We're going to continue tutorial 8. In the first part we talked about zero-dimensional objects, points, and putting color into your graphic. Now we're going to head up a dimension into one-dimensional objects, line segments. In order to create line segments, you use the line command. So the line command takes as an input a list. It has the first point, it has the last point, and it has also, if you want, a bunch of intermediate points along the way. So if we look at this line object here, here is a line that goes from 0, 0 to 1, 1. And as before, you always need to wrap your primitives in a graphics command. So if we apply this, we get a line that goes from 0, 0 to 1, 1. Let's say we wanted to make these points have more points. So remember from above, we had our points that went from 0, 0 to 1, 1 to 2, 0 to 3, 1. If you take this list and you put it as the input to the line command, then you'll get the zigzags that come together. And you might want to include both the lines and the points together. So in that case, you can create this graphics object. Remember, if you want to put multiple things together, you have to put them into braces. So here's our list of points, and comma, here's our list, here's our line. It's a bunch of line segments. And when we do that, we get the combination of the line segments and the points. And so by default, these line segments are displayed without any axes or without any identifying markers. So compare these two pictures. Here is a picture of the points from 0, 0 to 1, 1, and from 1, 0 to 2, 1. They look exactly the same because Mathematica is giving you an optimal way. They've filled the whole output by what your object is. And since the objects look the same, they're just translations of each other, the output of these looks exactly the same. So if you want to be able to compare them, you would need to add in some other distinguishing characteristics. So here are some options that you can add at the end of your graphics object so that you can see everything, or you can put this in a window that you specify. So the first thing you should know is that you should use the plot range option to specify the window, the view window for your graphics object. So let's say you wanted to display your line segment from -2, 2 in the x direction and -2, 2 in the y direction. You can say, let's do this graphics. So what does this look like? We have a graphics object, a graphics command. The graphics that it's going to show is this line that goes from 0, 0 to 1, 1. And we'd like to specify that our window should be from -2 to 2 in the x direction and from -2 to 2 in the y direction. So these are the range of values. This is the plot range. These are the range of x values and the range of y values that are shown in the window. We're also going to add in this option that says that we do want to see the axes. So what do we get? We get the line segment from 0, 0 to 1, 1, where we've shown where the range is from -2 to 2, from -2 to 2, and we've put the axes on here, so we can really start to get the context for this line segment. And if we do it for that other line segment, from -1, 0 to 1, you get the exact same. You get the same axes and the same window, but you can see that this line segment is not the same as the other line segment. So If let's consider this example where we have our line segment. This is our first line segment. And we said, oh, this line goes from 0, 0 to 1, 1. But I only really want to show in that window from 0, 1, 0, 1. Now what we said before is that if you want to display multiple objects together, you use the show command. So this is our first object. This is our first picture, this one here. And the second one we want to show next to it. And so we'll use the show command to show both of them at the same time. Now, if you do this, the thing is that Mathematica will import the plot range and the options from the first object in the show command. So if you're using the show command and you're not seeing everything, it's probably because the graphics object that you have in the first object in your list of show has restricted what can be seen. So the way to fix that is to tell Mathematica that you want to see everything. And the way you do that is to use plot range arrow all. And that option will then show both of these line segments in the same picture. And this plot range all overrides the plot range that was specified in the first object. You may have noticed that every time I evaluate these, I've had to reduce the size of the box. And you can tell Mathematica exactly what size of the box you want. So this option is the image size option. So compare these two pictures. Graphics with an option of image size is 100. This is 100 pixels. And here, graphics with an image size of 200. So this is a 200 pixel box. All right, so just like before, I suggest going over to the Documentation Center and checking out the neat examples in the line entry, because you can do cool stuff. All right, so we've done one-dimensional things. Now let's talk about some two-dimensional things. All right, so when you're displaying a point in space, you can use the point command. You probably will want to use the disk command instead, especially when we get to 3 dimensions and we'll want to use spheres. You'll want to do that instead of using points, because points have no size. They're 0-dimensional. But these circles and the disks, those are indeed the right, they have a size. So there's 2 different commands, and you may wonder what's the difference. So disk and circle both create these circle objects. You can also use them to make ellipses, or maybe just parts of an ellipse or parts of a circle, so an arc. The difference in that is whether the object is filled in or is just the boundary of the circle. So let's look at the comparison here. So here I've created a whole bunch of disks. This is at 0, 0, 1, 0, 2, 0, 3, 0. And here are the circles at the same places, 0, 0, 1, 0, 2, 0, 3, 0. This point tells us what the radius is. So if I change the radius here, they all get a little bit bigger. 4, and they can all touch if they're all 0.5 away from each, if the radius is 0.5. I suggest also, just like before, we can use map objects to place these objects algorithmically. So here's a whole bunch of points, here's these points, and here's applying the circle to those points. Something fun we could do is add in some randomness. So let's create some coordinates that are random real values. So you can say, I want some random real numbers. So give me some real numbers between 0 and 1. And then I always forget exactly the right way to do this. 10, 2. So here we go. We have now 10 points that are all have coordinates between 0 and 1. So now if we do apply this same command where we say, I want to put a circle of radius 2 at each of these coordinates, there we go. Here now, these are the centers, and there now we've put circles of radius 0.2 at each of those centers. I think I'm going to make this a little bit smaller, 0.05, and here's something interesting. Of these random 10 points, these two were within distance 0.1 of each other. If we rerun the code, we're going to get different points. All right, good. When you apply color to a primitive, it colors the whole object. You may be interested in making an orange dot, but that has some color, some color on the boundary, right? So in order to do that, you use the edge form command. All right, so I suggest, again, heading over to the documentation center, look at disk. I think these are really exciting because they're so visual, and I guess I like to do visual things. So the basic idea here is that we've been talking about filled versus unfilled graphics objects, graphics primitives, and here we've been talking about disks and circles. And let's talk about one last type of object that has, and it can be filled or unfilled, and that would be the idea behind a polygon. All right, let me evaluate this and let me compare some different objects here. So how do you specify a polygon? You specify a polygon by saying what are the coordinates of each of the vertices of the polygon. So it depends on whether you want your polygon to be unfilled or filled. So just like the disk and just like the circle, so the disk was filled and the circle was unfilled. When you're dealing with a polygon is always filled. Whereas if you want to specify the edges of the polygon, instead what you're really creating is a bunch of line segments. And so use the technique from above to specify the lines, the coordinates of the edges of the polygon, the coordinates of the vertices of the polygon, and then create a line that goes between them. One difference here is that in a polygon, it's always expected that the polygon is closed. So if I specify 0, 1, 1, 2, negative 1, 5, that's going to give the polygon that's closed with those 3 points. On the other hand, if I specify the line that starts at 0, 1, goes to 1, 2, and goes to negative 1, 5, that's just going to give those 2 line segments. So if we want a closed polygon, we need to specify that the line ends at that at the first point in the list. And just like before, if you have a polygon and you want to specify its color and then the color of its edge, then you need to put the color beforehand and you need to put the edge form beforehand. And you can play around with those colors and the other modifications that you might make. So the last technique that I want to talk about has to do with using trigonometry to create regular polygons. So you may remember that a regular polygon, regular n-gon, is a polygon where each of the n edges is the same length and each of the n angles are the same. So what we can do is we can use Mathematica and the fact that points on the unit circle have the form cosine of theta sine theta to put the points on the circle and create a polygon. So here's what we're going to do. So we're going to create So we're going to say we want a polygon of radius 1. And we're going to create a whole bunch of points. So remember that a circle has a the angle of a circle that goes all the way around. It has is 2 pi radians. I guess I've written that here. A circle, you want to place the end vertices on the circle, and it has 2 pi radians. So what that means is we want to space them every 2 pi over n. So let's write this out. So if we look at this, if we create the range from 0 to 2 pi, and we go 2 pi over n, 2 pi over 5, that's going to give us the points that start out at 0, and it's going to go up to 2 pi, and it's going to increase by increments of 2 pi over 5. So if we now apply cosine of theta and sine of theta to this, so if we want to map what cosine of the function is, comma sine of the function is, to this output, that's going to give us the points that are distance, that are every 2 pi over 5. And then if we map a polygon to that, so if we do a polygon of those, coordinates, and we put that in a graphics object, then that's going to give us our polygon, our 5-sided polygon. That starts here at theta is equal to 0, touches here at theta is equal to 2 pi over 5, goes to theta is equal to 4 pi over 5, theta is equal to 6 pi over 5, theta is 8 pi over 5, and back to 2 pi. That gives our polygon. Similarly, if we wanted just the outer part, we can make it a line, and then we get the polygon, just the outside part. So here's a way to do this in general for any n. So if we change n to be equal to 8, we get our octagon. Mathematica already does have these regular polygons built in, using this thing called regular polygon. Regular polygon of 5 gives us a pentagon. Regular polygon of 20 gives us a 20gon. Great. So, and just like before, if we want to change the color, we can say, let's look at our octagon. We want to make a stop sign. Let's make it red. And every polygon has every octagon has like a white border around it. So what I'll actually do, let's see, what we'll actually do is we'll put a white boundary on the outside. But maybe we can't make it white because we won't see it. So let's do that. So we want to do edge form of white, but maybe we'll make it a darker white so we can actually see it. Right, what are we doing? You can really see it. You can start to see it, but you can't see it very much. So we need to say that we need to specify what the thickness of the border is. So the thickness of the border is going to be 0.2. You'll see that here I have a problem because edge form needs to have just one input, kind of like graphics. And now we've specified the thickness of this border is 0.2. That's a bit too much. The border 0.1, border 0.5. Now we're starting to feel like a stop sign, 0.4. This looks almost like what a stop sign would be. And let's make it a little bit lighter, even though we still can't see it, but we can start to see this faint outline for what if you were constructing a stop sign. All right, so that's enough for today. I'll see you next time. Bye.